Okay, so the question given is, just before 6 p.m., students enter the classroom to find Mr. Fees dead of an apparent homicide. At 6 p.m., the temperature of the body is 80 degrees, while at 7 p.m., it was 75 degrees. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? So to find the time of death, first we have to find the value of K, which is our decay coefficient. So here we're going to input 75 degrees into Newton's law of cooling equation because that is the temperature of the body after it has decreased. We're going to put 70 degrees here for T ambient because that is the constant temperature of the room, plus 80 degrees, the temperature of the body when it is found, the constant T ambient, and then again times e to the power of k times 60. We input 60 here because it took an hour for the body to decrease in 5 degrees, so we're converting that into minutes for 60 minutes. So to solve, we first subtract by 70, and that gives us 5 equals 10 e to the power of negative k times 60. We then divide by k, and that'll give us 1/2 equals negative k times 60. Since we're going to take the natural log of both sides, we can go ahead and move this power to the front, and that'll give us ln of 1/2 equals negative k times 60 times ln e. Since ln e is equal to 1, we can cancel that out. We're going to divide both sides by 60, and that gives us an approximate k of 0.01155. Now that we have an approximate value for k, we can input that into Newton's law of cooling to find the time elapsed. So here we're going to get 80 degrees, for that's the temperature of the body when it is found, equals 70 degrees, the constant, plus, here we put 98.6 degrees because that is the initial temperature of the body before Mr. Fees died, minus 70 degrees T ambient, which is the constant temperature of the room, times e to the power of negative k, which is this value here, times t. I stored this k value into my calculator, so I just left it there. To solve this, we're going to subtract by 70. That gives us 10 equals 28.6 e to the power of negative k times t. We're going to divide both sides by 28.6. That gives us 2.86 equals negative k times t times ln e. Again, this is equal to 1, so that cancels out. We're going to divide both sides by k, and that gives us an approximate time of 91 minutes elapsed. This is in minutes because this is also in minutes up here. So, to find the time of death, we look at the time that the body was found, which was 6 p.m. We're going to subtract 91 minutes, which was approximately an hour and a half, and that gives us an approximate time of death of 4:29 p.m.